Objective 2, synthetic division. We're going to divide two polynomials in this section. In this case, a third degree polynomial by x minus 2. High school, they teach you a long division process. We set this up like a long division problem. And I have it already worked out, but I'll talk you through it. We ask what times x is x cubed, that's x squared. X squared times x cubed. X squared times negative 2x squared. Subtract the negative is positive, negative 5 plus 2 is negative 3x squared. Bring down the 8x, and repeat. What times x is negative 3x squared, negative 3x, times x, negative 3x squared. Negative times negative is positive 6x. Subtract, those cancel. See, negative, positive, negative 3 plus 3 is 0. It's set up that way. 8 minus 6 is 2x. Bring down the 7. And repeat. What times x is 2x? 2 is 2 times x, 2x. 2 times negative 2, negative 4. 7 minus a negative 4 is 11. And we put the remainder over the divisor. It's plus 11. So, a little bit difficult. The problem with this is you're always subtracting across the polynomial. You have to distribute the negative. It's prone to error. It doesn't matter how good you are at math. If you do a lot of this rapidly, it doesn't matter how good you are, you're likely to make a mistake. Synthetic division replaces this process, and here's how it goes. Well, first of all, we copy the coefficients of the polynomial. 1, negative 5, 8, 7. Those are just the coefficients of the third degree polynomial. And then next we find the 0 of the denominator. Well, it's x equals 2, makes that 0. 2 minus 2 is 0. So this 2 we copy up here, right here. And then we make a box. You have to leave a space here. And then we bring the 1 down. And then we do 2 times 1. I'll just write times 2 here. And we get 2. Negative 5 plus 2 is negative 3. 2 times negative 3. I'll just write a little times 2 here. Normally you can leave that times 2 out, but I'm putting it here so you can visually understand what I'm doing. Negative 3 times 2 is negative 6. Negative 8 minus, or positive 8 minus 6 is 2. And multiply times 2 equals 4. 7 plus 4 is 11. And you put a box here because that's the remainder term. You should recognize these coefficients. They are the coefficients of this polynomial right here. Okay. Notice all we do, we multiply, added, multiply, added, multiply, added. And it makes sense that we could add because we copied positive 2 instead of negative 2. You see, you're multiplying by negative 2, then subtracting. That's the same as multiplying by 2 and adding. Less prone to error. Now from here, you have to be able to read the answer. This is always a constant term, x squared. Another way to figure it out is if you take a third degree, divide out one factor, it'll be a second degree polynomial. So this is 1x squared plus negative 3x plus 2 plus remainder over divisor, x minus 2. Once you learn the pattern, it's easy. Let's look at a couple more examples, and then I'll turn you loose on your homework. Now let's suppose we have x to the 4th minus 64 over x minus 2. Get rid of this clutter here. Well, the coefficients we're going to copy are 1x to the 4th, 0x cubed, 0x squared, 0x minus 64. You have to account for all these terms. If we just copy 1 and negative 64, you'd really be dividing x minus 2 into x minus 64. The whiteboard isn't intelligent. You can't read these exponents or read your mind. So we need a placeholder. The 0 is 2, so we put a 2 here. You can also remember it's the opposite of that number. If that were plus 2, that would be negative 2. That's negative 2, so it's plus 2. Draw our box, and then bring the 1 down. 2 times 1 is 2, add. 2 times 2 is 4, add. 2 times 4 is 8, add. 2 times 8 is 16, add. Negative 48. Box this in. Okay, fourth degree, divide out a linear factor. That should be a third degree polynomial. 1x cubed plus 2x squared plus 4x plus 8 plus negative 48 over x minus 2. Or you could just call that subtraction. Subtracting a positive, adding a negative, same thing. So that's synthetic division. There's not much more to it than that. By all means, practice your homework. Make sure you have the process down. It's worth doing a half a dozen problems so you can do it without thinking. So